I spent quite a bit of time on 5-4, number 7. We're supposed to be doing the problems in 5-4 by integration by parts. However, after quite a few efforts on this, I found out that you really can't do this one by integration by parts. You can get part way, but then you get stuck. Now, when you do integration by parts, the way I teach it, you make a little table and you try to decide what U is going to be and what V is going to be and what their derivatives are. So we could let X go here and arc tangent 2x dx go there. But then we have to know the antiderivative of arctangent of 2x, which is a little bit challenging. So normally we would put x there because this gets simpler. It'd be 1 dx when you take the derivative. So this is a bit of a challenge to do. Another option is to put the arctangent of 2x here, because we know its derivative, and put the x here, dx. That's antiderivative is x squared over 2, derivative of arctangent of 2x. Well, the derivative of arctangent of something is 1 over 1 plus the something squared times the derivative of the something, which is a 2 dx. Now, if we use that for u and v, we can get a little bit done. So the integral formula is uv, integration by parts formula, minus the integral of v du. So uv would be x squared over 2, or 1 half x squared times arctangent 2x minus the integral of these two. The 2's cancel and I get x squared over 1 plus 2x quantity squared dx. Now, before I go on, we could also have put all of this in here and use the product rule to take the derivative and just dx here. Turns out you end up with basically the same thing. The problem is, this is virtually, I did not find a way to do that piece by integration by parts. So with what we knew by the time we got to this section in the book, we get stuck here. So when I came back to class, I said, okay, there's a couple ways to go from here if we use tools we haven't learned yet. But we have now, and one of them is trig substitution on this part. So I'm going to step aside and do just the integral of x squared over 1 plus, that multiplied out is 4x squared, no quantity on that, dx. And if I'm going to do trig sub on just that part, I'm going to make a triangle such that I get 1 plus 4x squared and added, and I can get that on the hypotenuse because addition always ends up on the hypotenuse, 1 plus 4x x squared if I put like 2x here and 1 there. And then the trig sub rules are write something for x. Well, tangent of theta is opposite over adjacent, so that would be 2x over 1. So x is 1/2 tangent theta. That's my step number 1. My step number 2 is take the derivative, so we got something for dx. And so that's 1/2, and the tangent of theta derivative is secant squared theta d theta. And then we need something for the mess. And the mess, well, this is kind of the messy part. This is the mess squared because there's no square root. So the mess, let's see, if 1 over the mess is the cosine, so the mess over 1 is secant, is the square root of 1 plus 4x squared over 1. And so now I have something for this, something to replace the x with, and something for dx. So this would turn into the integral. The x squared would be 1/2 squared, which is 1/4, and tangent squared. And then the this denominator is this squared, so that's secant squared theta. And then the dx is 1/2 secant squared theta, d theta. All right, so the secant squareds can cancel. And so I got 1/2 times a 4th times 1/2, which is 1/8, the antiderivative of tangent squared theta d theta. Now that turns out to not be a simple integral either. And so then we brought in the tables that I gave out and handed out in class, and we notice that there's a tangent reduction formula, number 9 on this handout. It takes a tangent to some power and reduces it to the integral of a tangent of 2 less than whatever that power was. So if we follow this, my m would be 2. So I have 1/8 times everything I'm going to get in this reduction formula. And my m will be 2, so 2 minus 1 is 1. So I just got tangent to the 1, or just tangent x, over 2 minus 1, which is 1. So I didn't need to write that one. Minus the antiderivative of tangent to 2 less than 2, which is tangent to the 0, or 1, d theta. And so this reduction formula takes us to this, and now I have to integrate 1. Well, 1 dx would be x, 1 d theta is this theta. Plus c, of course, 1/8. So, oh, and this is not x, this is theta, because the page said x's, but my angle is theta here. So this is in thetas, but I have to go back to x's. Well, the tangent of theta is 2x over 1, or tangent of theta is 2x. And theta is if I solve for theta in this, I'd take the arctangent of both sides. The tangent inverse gets rid of that. Theta is the arctangent of 2x. So this is what I'd have to put in place of this. And so it'd be minus 1/8 times this plus c. This minus 1/8 times this plus c would be the answer to number 7. Now, that's using trig sub, which we hadn't gotten to by this point. Now, we are going to learn integration by partial fractions, and I'm going to do this integral one other way. I'm going to divide this into that using long division. So I'm dividing 4x squared plus 1 into x squared, just like it says. So when you do long division, you ask yourself, what do I take times this to get that? And I think that would be 1/4. 1/4 times 4x squared would be just x squared. But I have to take it times both pieces, so I'd have plus 1/4. And then when you're doing long division, you're supposed to subtract now. I like to draw the line and change the sign, so now I just add up like terms. These are like terms, they come out to be 0, and I'm left with negative 1/4. And the remainder, as you know, if you're dividing like 16 divided by 5, goes in 3. 3 times 5 is 15. Subtract, we get a remainder of 1, and you put the remainder over the divisor. So it's 3 1/5. Put the remainder over the divisor. So we get plus minus 1/4 over 4x squared plus 1. So this integral turns into the integral of 1/4 minus 1/4 times the integral of 1 over this, which is 1 plus 2x quantity squared dx. And the antiderivative of that, well, if it was twice this, the antiderivative would be arctangent of 2x. So that would be the antiderivative of this would be 1/2 arctangent 2x. And so we'd have, and the antiderivative of 1/4 would be 1/4 x minus 1/4 times that plus c, which if you look here, we got 1/4 x, and we got 1/8 times arctangent 2x. We have 1/8 times arctangent 2x plus c. So we can do it with this method, which is one of the steps in integration by partial fractions, or we could done it by trig sub, but we can't do that piece by integration by parts, which is the section this was in. So it's a nice segue into the things we're learning, but it wasn't possible to do with the methods we had at the time.